All right, so welcome to section 1.2. The title of session 1.2 is Linear Models and Rates of Change. So obviously in this section we're going to be taking a look at linear models. What does that mean to say linear models? Well, basically we're going to take a look at lines. Equations of lines, finding the equation of a line, all that stuff that goes along with it. So our competencies or our objectives for this section are to be able to find the slope of a line that passes through 2 points, write the equation of a line, if you're given enough information, interpret information about a line. Slope is a ratio of the rate of change in a real-life application. Sketch the graph of a linear equation and write equations that are parallel and or perpendicular. That shouldn't be too bad. So basically in this section, we're going to take a look at lines. Again, this is a review, so it is going to go kind of quickly. Slope of the line. Let's see. What is the slope of the line? Let's see. The slope of a line is the number of units the line rises or falls vertically for each horizontal change, each unit of horizontal change from left to right. Okay, so let's parse this out. First of all, we're talking about non-vertical lines because vertical lines do not have slope. Is the number of units that the line rises or technically falls, because it could go up or it could go down. And we're talking about the rise in a vertical sense for each unit of horizontal change. Now that word each right there is important because that word each right there says that the horizontal change is 1. And what we're measuring then is the vertical change associated with it. Now, I'm sure that at some point in time in your mathematical career, you've heard it written as rise over run, or change in y over change in x, or maybe you saw some notation like this, change in y divided by change in x, or something along those lines. Okay, so what we have is we have our definition of slope. Consider 2 points, x sub 1 and y sub 1, and x sub 2 and y sub 2 on the line in the figure at the right. So we're considering these 2 points right here. Whoa, wrong marker. Highlighter. This point and this point. That's our x1 and x2 and our y1 and y2. Now, a moment to talk about subscript notation. We use subscript notation in mathematics as a way to talk about multiple unknown values for the same variable. So to say x sub 1 and x sub 2 just means that there are 2 x values that we don't know. To say y sub 1 and y sub 2 means that there are 2 y values that we don't know. And traditionally, we put things together that belong together. That means that the x sub 1 goes with the y sub 1 and the x sub 2 goes with the y sub 2. So we want to keep things together that belong together. That kind of a deal. All right, so the horizontal and vertical changes can be found by using the formulas delta x equals x sub 2 minus x sub 1 and delta y is equal to y sub 2 minus y sub 1. So basically what we're calculating there is we're calculating the change from here to here in the x, as well as the change from here to here in the y. And the change on a set of axes is always found by taking the point to the right minus the point to the left. So the change in the x is the x2 minus the x1. The change in the y is the y2 minus the y1. And then if we make a ratio out of those 2 values, we get our slope. So there's our, oh my gosh, that's a typo. That should read delta y over delta x. Holy cow, I'm going to have to make sure I fix that. And I'm going to pause this video and go fix that so it's fixed on the one that'll be on the online for you guys. Okay, I'm back. I fixed it. So the one that's online in the files for you guys is correct. Okay. All right, so we make ratios, make slope, and this actually is our first introduction for this guy, M. Why on earth do we use the letter M for slope? There is no known reason. Some people make the argument that the guy who did a lot of the original work on this, original documented work, we'll call it that, was a French guy named René Descartes, also why this is called the Cartesian plane. There are some people who argue that because he spoke French, hence he was a French guy, that maybe there's a French word for climb, to climb, which is like monter or montier or something along those lines. So some people make that argument. Other people reject that. I've seen some fierce debates between mathematicians over that. I honestly don't know what the answer is, but I think that the guy being French and the word to climb in French starting with an M is a pretty strong argument for why it's M. But anyway, we use the letter M for slope for whatever reason. Okay. All right, so here we go. Here's our definition. The slope m of a non-vertical line passing through points x sub 1, y sub 1, and x sub 2, y sub 2 is the letter m is equal to delta y divided by delta x, which is found by taking y sub 2 minus y sub 1, dividing it by x sub 2 minus x sub 1. Okay. Slope is not defined for vertical lines. Now, why would that be? We'll take a look at that here in a second. Here are just some examples so you can see. All right. If a line, as you look at the graph from left to right, rises, so this line here, as we move from left to right, it goes up, it's rising, we would say that this is going to have a positive slope. And if we were to calculate the slope of this line, we would say that m is equal to the fraction y sub 2 minus y sub 1, so 1 minus 0, divided by x sub 2 minus x sub 1. And when we simplify that down, you'll see that we do get 1/5. What if a line doesn't change its vertical position? If it is a horizontal line, right? Now, one of the things that people say that just I always crack up is they'll say, oh, that's a straight line. Well, that's a straight line too. This is a straight line that happens to be horizontal, right? If we attempted to apply the formula, m is equal to y sub 2, 2, that's this value, minus y sub 1, 2, that's that value, divided by x sub 2, that's that 2, minus x sub 1, that's that negative 1. When we clean that up, we get 0 divided by 3, and 0 divided by 3 is indeed 0. So a horizontal line has a slope of 0. Please do not misinterpret this and say it has no slope. It has a slope. The slope is 0. Because remember, the slope is a way to tell the world about the vertical change of the line. So if you say that a line has no slope, you're saying that what are you saying? But if you're saying that a line has a slope of 0, you're saying that the vertical change is 0 as the horizontal change is 1. Remember, the definition back up here is the slope is the measurement of the number of units the line rises or falls for each unit of horizontal change. So a slope of 0 says that when x changes by 1, y changes by 0. A positive number for a slope, as an example number, as in this first example over here on the left, as in this one, says that as x changes by 1, a positive means y changes in a positive direction. A negative slope, like what we're looking at down here, just means that as x changes by 1, y changes by a negative amount. Okay? So then what is this right here? This is a vertical line. And if we attempt to apply the slope formula to this, we would have y sub 2, and I'll call that 4, minus y sub 1, that's 1, divided by x sub 2, so that's going to be 3, minus x sub 1, 3, and I get 3 divided by 0. Now, if you're in calculus, you already know that, hey, you can't do that. The division by 0 is no good. And so what is this saying? Well, remember what the definition said. Slope is the y change when x changes by 1. But on a vertical line, x never changes. And if x never changes, it can't have a slope. It is undefined. Okay? So remember that. All right, so equations of lines. We're about 10 minutes in, so we'll take a look at the 1 or 2 of these, and we'll call this video there. All right, so once we have a slope of a line, the next thing we can do is use that slope to find the equation of a line. The minimum requirements for finding the equation of a line are to know the slope and a single point somewhere on that line. Right? Once you know those, then we can use the point slope form for the equation of a line, which is this guy right here. And then we can plug in values and make it work. Now, one thing that people often get confused by in this point slope form of a line is what are variables and what are not variables. So I'm going to make this super big here, and I'm going to scream at you. This, wait, I don't want the highlighter, I want the orange marker. This is a variable. This is not a variable. This is the notation that we use to represent the known y value that is going to change for every problem. So this is going to be a number. Okay? This is going to be a number. It is the slope of the line. This is a variable. We leave it as a variable. And then what's this? This is the notation, the symbol that we use for a x value that will be known in the problem, and we'll plug it in as a numerical value. So these two guys will stay variables. Everything else will be replaced with a numeric value, and then you'll do some algebraic manipulation to clean this thing up. Okay? All right, so here's our first example. Find the equation of the line that is with the slope of 3 and passes through the point 1, -2. Now, let me give you some help here in your future math classes. Okay? You should always start out when you're doing a problem like this, or any other problem for that matter, you should always start out by simply putting down the formula that you're going to be using and then doing your substitutions. If you just start straight into throwing numbers in there and you make a mistake, your instructor might not be able to tell where you started, what you started with, and then might not give you credit for it in the proper way. So since I'm finding the equation of a line and I'm going to use the point slope formula, the first thing I'm going to do is I'm going to write down what I'm using. Then I'll do my substitutions. Remember, y is a variable, stays a variable. Y sub 1 becomes the variable value from the point. Okay. M3 from the problem. Okay. Now, I know what some of you are thinking. Can't you do some of that math in your head? Yes, I can do some of that math in my head, but I want to just put down all the steps so we're clear. Now at this point I need to decide what I want to do with this. Do I want to put this in general form, or do I want to put this into slope-intercept form? Most of the time, usually it is useful to have this in slope-intercept form. So in slope-intercept form, I'm going to kick this over to the right-hand side, and I will get that y is equal to 3x minus 5. And that'll be my slope-intercept form of the line. But occasionally, we might have purpose or use to put this into general form. And in general form, I would also move this to the left, and I would get -3x plus y is equal to -5. And this would be on our general form. Now, neither of these is the correct form for this problem because the directions did not state. They just said find the equation of the line. Either of these would be correct. Which one should you use? Well, in general, I would say do the one that they tell you to use in the directions. If your job is to then take this thing and graph it, I would probably put it into slope-intercept form. If this is going to be an equation that I'm going to be using to solve within a system of equations, it might be beneficial to leave it in general form, to put it into matrix form and do some sort of Gaussian elimination or whatnot on. So it really depends on the intended use of this. Right? Now, since this didn't say, and I can choose, I would choose this one, just simply because that seems to be the one that we use more often. Okay. All right. Find the equation of a line with a slope of -5 and pass through the point -6, 4. Now, if I were you, what I would do is I would pause the video right here, work this problem out, see if you get the same answer as me. So first thing I'm going to do is write down the formula that I'm using. Then I'll start plugging in the values for the knowns. So y minus 4 is equal to -5 times x minus a -6. Y minus 4 is equal to -5x minus 30. And then y is equal to -5x minus 26. And so there's my final answer. Okay, so I found the equation of a line with a given slope passing through a point. These two problems that we just did right here are in terms of finding the equations of line, about as easy as it gets. You're given the slope, you're given the point, make it happen. There's really not too much that can go wrong. Now these next two problems, they're like a level 2, because if you take a look at both of these, both of them ask us the same thing, find the equation of a line, but they no longer give us the slope. They just give us 2 points. So a moment ago, I told you that the minimum requirements for finding the equation of a line were a slope and a point. That's the minimum. I don't have that though, so what I need to do is I need to turn this into a minimum. I can always take 2 points and turn that into a slope. So the first thing I'm going to do is I'm going to take these 2 points right here and make those into a slope. Do you remember how to make those into a slope? There's a formula for it. M is going to be equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's going to be a negative 1 over a negative 2, which I believe is 1/2. And then I'll take my point slope formula, y minus y1 is equal to m times x minus x1, plug it in. I'm going to use this point and not this point just because I like smaller numbers. So y minus 4 is equal to 1/2 times x minus 1. Y minus 4 is equal to 1/2 x minus 1/2. Y is equal to 1/2 x. Let's see, when I take that minus 4 to the right, it becomes a positive 4, so plus 3.5. So what's that, 7/2? So plus 7/2. And there's my slope-intercept form for the line that passes through those 2 points. I would pause it right here and check and see if you can do it without me. So let's see. First thing I'm going to do is find my slope, m. M is equal to y sub 2 minus, whoop. Hey, wait a second. 0 over 6. My slope is 0. What does that mean? Well, that means what we have here is we have a horizontal line. And what is the equation of a horizontal line? Well, the equation of a horizontal line is always y equals b, where b is equal to the y value of any point on that line. So in this case, if you notice, both of our y values are 5. So our equation is y just is equal to 5. All right? So I'm going to stop it right here and come back, and the second part of this video will be graphing linear equations and then more from there. I'll see you soon.